Hello all. This video is a continuation of memory of 8086 microprocessor. So this is a slide which we have seen previously. The thing is like when it is 000, interrupt acknowledge. When the status signals S0, S1 and S2 are are in the sequence of 001, then it means that it is input output read. When it is 010, input output write. 011 means halt. 100 is nothing but opcode fetch. 101 is memory read. 110 is memory write. And triple one is nothing but passive or the halt status. So 8086 is having some control signals like ALE, BHE, memory input, data transfer receive, read and write, and arithmetic logic enable, data enable, read and write signals. So these signals usually control the device 8086 microprocessor. Microprocessors usually refer to the use of multiple processors that execute instructions simultaneously and communicate with each other using mailboxes and semaphores. Usually, microprocessors are the basic devices which is used for processing the data, which would be especially used in CPUs where the process takes place for a long time, but it's like microcontroller will be giving instructions to the users or the end users, displaying informations. So it's like where microprocessor is nothing but a basic one when compared to the microcontroller, where we can program arrays and but this is like continuous processing. 8086 is nothing but one of the kind of a processor which is used for communication and the continuous long run process. The maximum mode of 8086 is designed to implement three basic microprocessor configurations. The very first one is coprocessor, closely coupled and loosely coupled. 80 coprocessor is nothing but 8087. Closely coupled is 80889 and loosely coupled is multibus. These are the co-processors which will be having similar architecture, similar working principles, and similar components, but it's like these are like sequential innovations. Co-processors and closely coupled configurations are similar in that in both in 8086 and the external processor. These usually shares the memory, the input-output system, bus, and the bus control logic, and even clock generators will be there. So we have the block diagram of coprocessor or the closely coupled configuration. Clock signal will be there. The clock signal will be given to the 8086 processor. The duplex signal from 8086 processor will be given to the coprocessor or independent processor. And from the coprocessor also, signal goes to the 8086 86 microprocessor. The data will be then given to the bus control logic. From the bus control logic, it will be given to the system bus, and through the system bus, it will be given to the memory data, memory stored in the memory, and also in the I/O device. Test pin of 8086 processor. It is used in conjunction with the wait instruction in multiprocessing environments. This is input from 8087 coprocessor. This usually used to execute wait instruction. The CPU checks these kinds of signals. If it is low, execution of the signal will continue. If it is not zero or if it is not low, then execution uh, will get stopped. That is a actual process. Here we have a flow diagram from 8086 to 80, 8086 or 8088. Both are like innovations. First ESC, wake up the processor, execute the instructions and wait. So first is like wait, execute, start, execute, and then wait. So monitor the in the meanwhile while waking up, monitor the 8086 or 8088. we have to deactivate the host, test the pin and execute the specified operation, and then activate the test pin. So these are the processes which happens. Closed loop execution example. Another example is shown here. This is also a flow diagram. Closely coupled processor may take control of the bus independently. So here is a flow diagram. Setup message, wait for the request, fetch the message, perform the requested task, and notify the CPU of completion. So, and this is the like the flow diagram for closed loop execution example. I hope you would have learned from this video. See you in the next video. Until then, it's bye from Radhika.